Good day, everyone. So I am Marian Angel Pilon. So today we'll be talking all about radiation chemistry. So let's get started. So radiation chemistry is a subdivision of nuclear chemistry in which implies the chemical effects of ionizing radiation with matter where they interact with. So as a result of energy absorption is the breaking or arrangement of chemical bonds, like the composition of some of the initial molecules and formation of new ones. So later we'll be discussing it further. So radiation chemistry is completely different from radiochemistry. So we shouldn't be confused with radiochemistry, as no radioactivity needs to be present in the material which is being chemically changed by the radiation. So next one is radiation chemistry traces its origin to the discovery of X-ray or Roentgen X-rays by Wilhelm Roentgen in 1895, and of the radioactivity by Henry Becquerel in 1896. So X-rays and uranium salts were shown both to be fact-packed photographic films, and they were shown to produce electrically charged ions and other gases. It was also shown that the decomposition of water, a mixture of hydrogen and oxygen, was produced. So this results clearly demonstrated that the radiation exerts physical and chemical effects on the material irradiated. So as well as the discovery of radioactivity by Henry Becquerel follows the discovery of radium by the Marie Curie and Pierre Curie in 1898. So the biological effects were also discovered very shortly after the discovery of ionizing radiation. So ionizing radiation penetrating the matter causes excitation and ionization. So ionizing radiation can dissipate or release their energy by two methods, excitation and ionization. So the result of an interaction between the radiation and the absorbing species is removal of an electron or molecular band to form radicals in excited species. So excitation is amount of energy absorbed raises an electron in atom or molecule to a higher energy level without ejection of the electron. So example is the following exposure to radiation is UV rays. So next one is ionization. So ionization occurs when the absorbed radiation has enough energy to eject one or more orbital electrons from the atom or molecule. So example is radiation with such energy called ionizing radiation, X-rays and gamma rays. So interaction between the radiation and the absorbing species is removal of an electron from an atom or molecular band to form radicals in excited species. The radical species that then proceed to react with each other or with other molecules in their vicinity. It is the reactions of the radical species that is responsible for the changes observed following irradiation of chemical system. So charged radiation species such as alpha and beta particles interact through Coulombic forces. So Coulombic forces are the electrostatic charges between the charges of the electron in the absorbing medium and the charged radiation particle. This interaction occurs continuously along the path of the incident particle until the kinetic energy of the particle is sufficiently depleted. An important factor that distinguishes different radiation types from one another is the linear energy transfer, or LET. So which is the rate at which the radiation loses energy with distance travel through the absorber. So low LET species are usually low mass, either photons or electron mass species such as beta particles or positrons and interact thinly or sparsely along their path through the absorber or milieu, leading to isolated region of reactive radical species. While high LET species are usually greater in mass than 1 electron, for example is alpha particle, the lost energy rapidly resulting in a cluster of ionization events in close proximity to one another. So consequently, the heavy particle travels relatively small, relatively shorter distance from its origin. So let's back up the slide. So I forgot to discuss this. So direct effect of radiation, of ionizing radiation. So definitely is the excitation and ionization of water by the secondary electron is the predominant reaction in biological systems for low LET radiation. So the initial reaction occur on a time scale of 10 raised to negative 16 to 10 raised to negative 12 seconds. So this time scale produces the initial product, which we will discuss later. So yeah. So both the harmful effects of radiation upon biological system is the induction of cancer and acute radiation injuries, and the useful effects of radiotherapy involve the radiation chemistry of water or radiolysis. So this one. So the overall process of forming chemically stable products after the absorption and redistribution of the excess of energy of ionizing radiation. So the resulting compounds from radiolysis is called, or simply refer as radiolytic compounds. So the vast majority of biological molecules are present in an aqueous medium when water is exposed to radiation. The water absorbs energy and in results forms chemically reactive species that can interact with dissolved substances or solids. So ionizing radiation produces abundant secondary electrons that rapidly slow down and thermalize to energies below 7.4 electron volts, the threshold to produce electronic transition in liquid water. So for both the primary charged particle and the secondary electrons, this slowing down process is accomplished by transfer of energy to the milieu in a sequence of discrete events. So these discrete events are initial physical events and pre-chemical reactions and chemical stage. So later we'll be discussing that. So before that, let's first tackle the course of event, which accounts for the production of this species takes place when a fast-moving particle passes through water. So the consequential loss of energy gives rise to localized concentration of ions in radicals that involves nanosecond pulse radiolysis or time scale. So individual or unique time scale technique which confirm the localized concentration of radicals produced. So the conjuncture of ions and radicals which forms spurs, blobs, and tracks. So spurs are the pairing of ions when ionizing radiation interact with water. So it produces secondary electrons that pair with ions, that is called spurs, while blobs is the cluster of spurs, while short tracks are the short tracks. So when ionizing radiation interact with let's say when the high energy level moves through matter, it loses its energy. So that energy produces short rocks. That produces short rocks. Yeah. This products this products gives rises depends on the fast-moving particle, in which we're talking about the ionizing radiation. So let's go on. So these events are, so for example, we first from 6 to 100 electron volts, they produce in the approximate energy of 6 to 100 eV, while blood is produced from 100 to 500 electron volt, while short rock is produced from 500 to 5000 electron volt. So this is the diagram. Yeah. So let's go on to the discrete events. That a sequence of discrete events happen in the transfer of energy in the medium. So we have initial physical events. So the initial event is a transfer of 7 to 100 electron volts, an amount of energy sufficient to cause multiple ionization or excitation in water molecules. So through ionization and excitation, the passage of a charged particle to biological medium produces or creates 3 species in the local vicinity of the particle trapped. So direct ionization of water produces a radical ion in a free sub-excitation electron. So this one. So when ionizing radiation interact with water, the initial product yields as the radical ion and free sub-excitation electron. So energy transfer can produce a water molecule in an excited state. So the time scale for this creation for this species is in the order of 10 raised to negative 16 seconds. So for the second event is the produced initial species in the first event begin to diffuse and react with each other, other molecules in the medium. So some of this reaction produce radicals. So what is radicals? So radicals refers to an atom or molecule that contains an unpaired electron. They are highly reactive but can be neutral or charged. So the electron is captured by water through dipolar interaction, becoming solvated and referred to as an aqueous electron or a solvated electron. So the solvated electron plus water produces a aqueous electron that can react with hydrogen to form a radical. The radical ion of water can dissociate to produce a hydroxyl radical and a hydrogen ion. So the excited water molecule can dissipate excess energy by bond breakage to produce hydroxyl and hydrogen radicals. So it takes 5 electron volts to break the oxygen and hydrogen bond. So the actual concentration of the radicals are very small, especially when compared to the concentration of ions present from the dissociation of water. Thus, the 3 initial species, the radical ion of water, water radical and electron, react further to produce chemically reactive species, the hydroxyl radical, hydrogen radical, and aqueous electron or solvated electron. So water hydrolysis produces highly reactive hydroxyl radical and hydrogen radicals. These radicals are much more reactive than hydroxyl and hydrogen ion from ionic dissociation. So hydroxyl radicals are a powerful oxidizing agent. They are very reactive chemically. So we all know the concept of oxidation reduction. So oxidation is the loss of electrons. The electrons are transferred to the oxidizing agent, which becomes the juice, while reduction is the addition of electrons. may involve the addition of electron only or the addition of hydrogen together with an electron. So let's go on to the final stage, the chemical stage. So after 10 raised to negative 12 seconds, the chemically reactive species are still located in the vicinity of the original water radical and radical ion of water and electron species that cause nucleation. 3 of the new species created are radicals. So the 3 radicals. So these species now begin to migrate randomly about their initial position. So as this diffusion proceeds, individual pairs may come close enough together to react with each other. So a variety of reactions are possible in the track of the charged particle. Most of these reactions remove chemically reactive species from the system with time by 10 raised to negative 6 seconds. So all of the reactive species have diffused sufficiently far that further reactions are unlikely. So the chemical development of the track is over by 10 raised to negative 6 seconds. So the yield or the product or the species from chemical stage is this one. So they are considered insignificant when compared to the 3 initial species, the radical ion, the water radical, electrons, and radical ion of water. So this one. So most of this reaction remove chemically reactive species from the system with time. So I already discussed that. So okay, so that would be all. So thank you.